I hope you took occasion to try to identify some of the issues with this code we've written. I also identified one while I was reviewing the last video. I made a mistake, and it wasn't the mistake I was expecting you to find. It's just I want to change something back. Notice total here. I said we were going to store that in EAX, but I actually took occasion to make a variable for it. There's an advantage and disadvantage. I do want to talk about the advantages and disadvantages. Making a variable called total has meaning to me, whereas ECX, now I have to kind of keep this mental indirection that ECX means total, and I have to refer to that right here. So it's more advantageous to use a variable like so, because then in our code when we say total, we know what that means. However, RAM, accessing memory, is slower than accessing a register. A register is built directly on the CPU, and I want to keep as much data in the registers as possible, and I want to access RAM as little as possible. Now there's caching and L2 and level 1 and level 2 cache and all those kind of things I don't want to get into right now. And it is expensive. How much more expensive it is to access memory, I cannot tell you. It is more expensive if we have a cache miss, which is something I haven't taught you about. But long story short, if we can keep it in a register, let's do. So I'm going to eliminate total here. And then everywhere I see total, I'm going to replace it with the register that I meant to keep track of everything in. So this will be ECX, and this will be ECX. I'm going to hit Control Home, go to the top of the file, Control I, and just search for TOTAL. That's an incremental search in Visual Studio. You see I have the binoculars, and it will search directly down. Anyway, Control F would have kind of done the same thing, but Control F brings up this window, and then I have to say total, then I get all these options and have to worry about that. Sometimes if you just want to find something quick, Control I and type it. Okay, and you can do Control Shift I, and that will take you backwards. Notice my cursor has a green arrow pointing up now, and so if I type, let's do D word, it will search up, so on and so forth. I can type stack, and that will search up. Anyway, hopefully you're learning some hotkeys from me as we go along. Now that total's gone, we also need to initialize total. So move ECX 0. Actually, let's do the XOR trick. XOR ECX ECX. That will zero out ECX as well, and supposedly that runs faster too. Again, one thing, though, as a programmer, when somebody says something's faster, don't just jump on the gun and say, ooh, I'm going to do that all the time because it's faster. Well, how much faster is it? I personally drive pretty slow on the interstate. I'm the guy that's always getting passed. But what's funny is generally the people that are passing me, I eventually catch up to because they get stuck in traffic. And it's even worse when there's traffic lights, maybe not on the interstate, on some highway where there's traffic lights. People zip by me, and I'm kind of the tortoise that's going along, and I'll still catch up to them. All right? So just because somebody says something's faster, don't just jump on it. All right? Do your research, use a profiler, figure out exactly how much faster is it. Now, we're 3 minutes into this video, but there are issues with this code that I was hoping you would catch on your own. If not, let's see if we can discover them. F11, start the debugger up. You'll see I've put the registers in the memory down here because things are starting to get a little bit cramped. I'm going to take this off the screen. Control-Alt-D, go into our doit-proc. Let's run our initialization code. So move into EBX the value 2. And then XOR ECX with itself, that zeroes out ECX. And then add to ECX the value that is sitting at this memory location. What are we doing here? Do you remember? This is kind of hard to digest. And unfortunately, we're not debugging our original code. We're viewing the code, the disassembled code. The assembler assembled it, and now the debugger is disassembling it. So pretty much all of our variable names and most of the labels are gone, not all of them. Okay, this is a label we'll get to in a future video, talk about why that label survived versus other labels not surviving. What is this memory location referring to? Let's go to our original assembly code, and we're right here, add ECX, the power. Well, we're trying to add this first power right here, this 2 to the 1. So add ECX power. So that memory location right here represents our power, and I can copy this and go down here and paste it right there and hit enter, and sure enough, here is our current power, all 4 bytes. Remember, power, if I go to my assembly.asm, power is a D word, which makes up 2 bytes. But then where's count sitting at? All right, count, we put count right above power here, which means in the executable program that we're debugging right now, in memory, this should be the 4 bytes that come before power. Alright, so let's just scroll up here a little bit. And these 4 bytes right here should represent count. Alright, well, this is kind of complex. Look at all these hexadecimal numbers. And this is count, and this is power, and I can see why people say computer programming is for geniuses. It's not. It's just a matter of keeping track of the bits and the bytes. Let's see if we can simplify our approach. I want to find our first reference to count, which I believe is right here. We do this increment to count. So let's go back to our disassembly and find that increment. And increment this address. That should be the address of count, which is 4 bytes. See that? This is count. This is power. I told you count would be the first 4 bytes before power. So let's actually go like this. I'm going to copy this, and well, I guess I could just drop this 4 to a 0. That would accomplish the same thing. And then let's highlight here. We'll go with blue. This is our count. I'll just label it like that. Keep track of it for us. And this is our power. And I don't need to jump around in these windows because all I'm doing is 2 variables. And you can see I'm looking at them just like registers. I mean, are these not 4-byte values that we're looking up right here? But instead we're doing 4 bytes in memory like so. So there we go. There's our count. There's our power. And we know that count is at the 0 location. So that's our count. And then our power starts at the 4. So this is power. This is count. These are memory addresses. Okay, hopefully that's nothing new to you. Let's find our yellow line where we're at. Let's add to power, or let's add the value that's in our current power to ECX. ECX is currently 0. ECX is our total. So there we go. We've got the 2. Let me bring this back up. We've just added 2 to the 1. That's where we're at in our program. Okay, next step, let's move the power into EAX so that we can multiply the EAX against our base. Do you remember that? So power right now is 2. We're going to put it in ECX. ECX has some arbitrary value right now. So F11, it's 2. Let's do the multiply, our base against our power. So 2 times 2 makes a 4. Then we need to move it back out to this memory location, which is our power. So this 2, we'll copy that 4 out to here, and so that 2 becomes a 4. Now, if I bring up this again, we're at 2 to the 2. Okay? The next thing we need to do is add that to our total. We've raised 2 to the power of 2, so now we need to add that to our total. Let me bring this back here. Where's our total being stored? That's in ECX. So add the value that is at power to ECX. So 4 plus 2 makes 6. Okay, our next step is to do this multiply. But before we do the multiply, we need to again raise our power to the next level of 2. Okay, our power is at 4. We need to take it to an 8. So let me get this off the screen here. And again, it's that 3 lines of code I copied and pasted. Move it into EAX, raise it to the power, move it back out to the power location in memory. So move EAX to power. That doesn't accomplish anything because we just copied this 4 back out to where it was at. So we could probably just delete that line of code in our original program. It doesn't accomplish anything. Multiply. So again, let's raise it to the next power. Pop. We got an 8. Good. Let's take that 8 and shove it back out to the power location in memory. F11. Very good. And now we need to do the multiply. So let me bring the original program back up. We've just raised this 2 to the next power. Now we need to perform this multiplication. Alright. Well, guess what we do again? We are going to move power back into EAX. But again, this is another useless operation because power is 8. EAX is 8 already because we just finished doing the power multiplication there. But there we go. Let's put that in anyway because I copied and pasted that code. Remember that 3 lines of code? I copied and pasted down here. So F11, multiply EAX against ECX. And ECX is our total. Thus, that command right here is performing this multiplication right there. So let me come on off the screen. EAX and ECX. What is ECX? ECX is a 6. EAX is an 8. We should get a 48, but again, this is hexadecimal. So let me bring the chart back up again. And 48 in hex is a 30. So this should change to a 3, or EAX should change to a 30. There we go. And now let's move that result. That's our running total now. Let's copy it out to ECX. 30. Increment our count. Remember, this represents our count address right there. So increment count to 1. Compare it to 5. Jump less than. If it's less than, change the instruction pointer. Remember the instruction pointer here? And it is less than. Remember, jump less than checks the sign flag and the 0 flag, and we'll jump. Actually, it only needs to check the sign flag. If sign flag is 1, meaning we have a negative value, then sure enough we need to go to this memory location and start executing there. Where is that memory location? 21017. 21017 right here. We're going to jump to right here and perform our loop again. Now let's trace a little bit further, and then I'm going to end this video and point out a few other things to you. What is this instruction doing? Add ECX dword. I'm going to bring up our original problem. We just completed this multiplication. We need to now perform this addition. And it looks like we're doing an addition. Are we doing the correct addition? Let me take that off the screen. We're going to add to our total the value that is sitting at this memory address, which is our current power. Alright, our current power is at 8. I'll bring this back up. And 2 to the 4, we're trying to add to the 4. 2 to the 4 is not 8. It's 16. Oh, there's one bug, right? And that's actually the initial bug I could see as we were entering into this. There's other issues as well, but there's one bug. Right? How could we modify our program to get rid of that bug and operate correctly? And then I encourage you to trace through this. One other issue I want to point out is our count right now is at 1. All right? But we have just completed 2 to the 3. And yet our count is stuck here down at 1. Our count should be at 2 to the 3. So there's another bug as well. Generally with loops, we do set up a counter and we just say count, increment, compare. Count, increment, compare. The exact same thing we're doing right here. Increment, compare, that, and then jump, that sort of thing. But in our loop, we're doing 2 operations per loop. We're doing the addition and we're also doing the multiplication. All right, so we need to do something a little different here. Let's address that in the next video.